Why is the load connected to the power supply side for NMOS, while the load is connected to the ground side for PMOS? Welcome to YB's Science Corner. Taking NMOS as an example, its conduction condition is VGs. If the load is connected to the power supply side and the source is grounded, the gate voltage only needs to reach 5 volts to satisfy the condition. For instance, if the buzzer's voltage drop changes from 1 volt to 1.2 volt, the transistor remains stably conductive as long as the gate voltage remains 5V and does not exceed its rated value. However, if the NMOS load is connected to ground, the situation changes. VGs must overcome the load voltage drop to meet the threshold voltage. For example, with a 1 volt load voltage drop, the gate voltage must reach 5 volts plus 1 volt, totaling 6 volts. For conduction to occur, if the load impedance increases, causing a 1.2 volt voltage drop, then 6.2 volts is required for conduction. Now consider the PMOS transistor. Its conduction condition is VGs, meaning the source voltage must be at least the threshold voltage higher than the gate voltage. For example, at 5 volts, if the load is connected to ground and the source is connected to the power supply. When the gate voltage decreases, the voltage difference between source and gate more readily reaches the conduction threshold. If the PMOS load is connected to the power supply terminal, the load voltage drop will reduce the voltage difference between the source and gate. This may prevent VGs from reaching the negative threshold required for conduction, causing the transistor to fail to turn on or operate unstable. That wraps up this episode's video content. If you have any questions, feel free to leave a comment below. Goodbye.